Today we're talking about current electricity. It's called current, and the symbol for current is capital I because it moves or flows. So current electricity is basically a controlled flow of electrons through wires, toasters, light bulbs. All those things are called loads. So anything that uses a current or electricity can be called a load. So your computer could be called a load. Current is measured in a unit called amperes. The symbol for amperes is capital A. The device we use to measure current is something called an ammeter, and it must be connected in series. What that means is if you wanted to figure out the current that's flowing into a light bulb, you have to put the meter either just before the light bulb or just after the light bulb. There are certain rules for current. So to understand current, we must understand how it behaves in parallel and in series circuits. We're going to start with parallel. So this is an example of a parallel circuit where it has branches. The current can flow through this part, or this part. In this case here we have 3 branches, but it could have more or less. IT is the total current. T stands for total, and that's the amount of current coming out of the battery. I1 is just the current in the first light bulb, I2 is the second light bulb, I3 is the current in the third light bulb. Now the rule for current in a parallel circuit is that if you add all the individual parts together, it equals the total. So the sum of the individual currents will equal the total current in the circuit. For instance, if I had 20 amps, which are 20 packages of electrons coming out of the battery, 10 could go down this way, 5 could go down this way, 5 would also go down this way, and if I add 10 plus 5 plus 5, it would give me the total, which is 20. Next, we have series circuits. In a series circuit, which is just one continuous loop, the current is the same everywhere in the circuit. So the total current, IT, that comes out of the battery will be the same in the first, in this case I drew a resistor, or the second resistor, or the third resistor. So let's say in this example I had 20 amps coming out of the battery. 20 packages of electrons have to go through the first resistor. 20 packages of electrons, or 20 amps, has to go through the second resistor. And 20 will have to go through the third resistor. So in a current stays the same no matter where it's measured.